question of whether installing a subpanel in bedrooms specifically for arc fault circuit interrupter or AFCI protection is code compliant requires careful consideration of the National Electrical Code, or NEC. Specifically, the NEC does not explicitly address this scenario directly, but several sections are relevant to its interpretation. Firstly, Section 210.12 states that branch circuit protective devices shall be listed to provide protection of the entire branch circuit. Secondly, Section 408.3b states that arc fault circuit interrupter protection for a branch circuit shall be provided by a listed device that provides protection of the branch circuit. To understand the implications, it is crucial to differentiate between a feeder and a branch circuit as defined by the NEC. A branch circuit is defined as a circuit that extends beyond the final overcurrent device protecting the circuit. Feeders, on the other hand, supply power to the subpanel from the main panel and are not technically part of the branch circuit protected by the AFCI breakers within the subpanel. Given this distinction, the core issue lies in whether the feeders supplying the subpanel are adequately protected according to code if only the branch circuits originating from the subpanel are AFCI protected. Based on the NEC definition of a branch circuit, it can be argued that installing a subpanel in the bedroom solely to provide AFCI protection might not be fully code compliant. The reason is that the feeders supplying the subpanel would not be protected by AFCI devices, which could be seen as violating the requirement for protection of the entire branch circuit, if one considers the entire run from the main panel to the bedroom receptacles as a single branch circuit. However, there could be a different interpretation, and the local electrical inspector is the final authority on interpretations. A more definitively code-compliant solution involves installing AFCI breakers directly in the main panel to protect the branch circuits serving the bedrooms. This method ensures that the entire branch circuit, including the feeders, is protected by AFCI devices from the main panel to the furthest outlet. This approach aligns more closely with the intent of the NEC to provide comprehensive AFCI protection for bedroom circuits. While technically feasible to install a subpanel for AFCI protection, it is unlikely to be considered fully compliant with the NEC intent. The preferred and more straightforward method is to use AFCI breakers in the main panel and run new AFCI-protected branch circuits to the bedrooms, ensuring complete protection from the origin of the circuit. When evaluating electrical installations and code compliance, always refer to the specific edition of the NEC adopted by the local jurisdiction and consult with a qualified electrical inspector or engineer to ensure compliance with all applicable regulations. The alternative solution of using AFCI breakers in the main panel offers several advantages. Firstly, it provides complete protection of the entire branch circuit, from the main panel to the outlets in the bedrooms. Secondly, it simplifies the wiring and reduces the number of components needed, as there is no need for a separate subpanel. Thirdly, it is a more straightforward and widely accepted method, making it easier to obtain approval from electrical inspectors. When installing AFCI breakers, it is important to follow the manufacturer's instructions and ensure that the breakers are properly sized for the circuit. It is also important to test the AFCI breakers after installation to ensure that they are functioning correctly. AFCI breakers are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when there is a break in the insulation of a wire, or when there is a loose connection. When an arc fault is detected, the AFCI breaker will trip, cutting off the power to the circuit and preventing a fire. AFCI breakers are required in bedrooms in many jurisdictions, and they are recommended in other areas of the home as well. They are an important safety device that can help to protect your home and family from electrical fires. In addition to AFCI protection, it is also important to have ground fault circuit interrupter, or GFCI, protection in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. GFCI breakers are designed to detect ground faults, which are electrical conditions that can occur when there is a path for electricity to flow to ground. Ground faults can be caused by wet conditions, damaged wiring, or faulty appliances. When a ground fault is detected, the GFCI breaker will trip, cutting off the power to the circuit and preventing electric shock. GFCI protection is required in many areas of the home, and it is an important safety device that can help to protect you and your family from electric shock. When installing electrical wiring, it is important to follow all applicable codes and regulations. It is also important to use high-quality materials and to ensure that the wiring is properly installed. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electric shock and fire. Here are some additional tips for electrical safety. Firstly, never overload electrical circuits. Secondly, use extension cords sparingly and never use them as a permanent wiring solution. Thirdly, inspect electrical cords and appliances regularly for damage. Fourthly, replace any damaged cords or appliances immediately. Fifthly, keep electrical outlets and appliances away from water. Sixthly, never touch electrical equipment with wet hands. Seventhly, teach children about electrical safety. Eighthly, have your electrical system inspected regularly by a qualified electrician. By following these tips, you can help to protect yourself and your family from electrical hazards. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC is developed by the National Fire Protection Association, or NFPA, and it is adopted by many jurisdictions throughout the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, electrical inspectors, and anyone else who works with electricity. In addition to the NEC, there are also many other electrical codes and standards that may apply to your project. It is important to check with your local jurisdiction to determine which codes and standards are in effect. When planning an electrical installation, it is important to consider all of the applicable codes and standards, as well as the specific requirements of the project. It is also important to consult with a qualified electrician or electrical engineer to ensure that the installation is safe and code compliant. The information provided here is for general guidance only, and it should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any electrical installations or modifications. In conclusion, while the concept of using a subpanel in bedrooms solely for AFCI protection might seem like a convenient solution, its compliance with the NEC is questionable due to the code's emphasis on protecting the entire branch circuit, including the feeders. The safer and more widely accepted practice is to install AFCI breakers in the main panel, ensuring comprehensive protection from the origin of the circuit. Always prioritize safety and adhere to the latest electrical codes and standards to prevent electrical hazards and ensure the well-being of occupants. The installation of a subpanel, even for a specific purpose like AFCI protection, introduces complexities that need careful consideration. Firstly, the subpanel itself must be appropriately sized for the anticipated load. Secondly, it must be properly grounded and bonded to ensure safety and prevent electrical shock hazards. Thirdly, the wiring methods used to connect the subpanel to the main panel must comply with the NEC. Additionally, the location of the subpanel must be accessible for maintenance and inspection, and it should be protected from physical damage. Furthermore, the subpanel must be labeled appropriately to indicate its purpose and the circuits it serves. All of these factors add to the complexity of the installation and highlight the importance of consulting with a qualified electrician to ensure that the work is done safely and in accordance with all applicable codes and regulations. The NEC is a living document that is constantly evolving to reflect changes in technology and best practices. It is important to stay informed about the latest updates to the NEC and to understand how they may affect your electrical installations. The NEC is available for purchase from the NFPA, and it is also available online through various subscription services. In addition to the NEC, there are also many other resources available to help you learn about electrical safety and code compliance. These resources include textbooks, training courses, and online forums. By taking the time to educate yourself about electrical safety and code compliance, you can help to protect yourself and your family from electrical hazard. The decision of whether to install a subpanel for AFCI protection should be based on a careful assessment of the specific circumstances, including the existing electrical system, the load requirements, and the applicable codes and regulations. It is also important to consider the cost and complexity of the installation, as well as the long-term maintenance requirements. In some cases, it may be more cost-effective and practical to simply upgrade the existing electrical panel to accommodate AFCI breakers. In other cases, a subpanel may be the best solution. Ultimately, the decision should be made in consultation with a qualified electrician who can provide expert advice and guidance. Proper installation and maintenance of electrical systems are essential for ensuring the safety and well-being of building occupants. Electrical hazards can cause fires, electric shock, and other serious injuries. By following the NEC and other applicable codes and standards, and by hiring qualified electricians to perform electrical work, you can help to minimize the risk of electrical hazards. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any electrical installations or modifications. It is also important to check with your local jurisdiction to determine which codes and standards are in effect. The NEC Section 310.15 contains capacity tables for conductors. These tables specify the maximum current that a conductor can carry safely based on its size, insulation type, and installation conditions. It is important to select conductors that are properly sized for the load they will be carrying to prevent overheating and potential fire hazards. The NEC Section 250 covers grounding and bonding requirements. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electric shock hazards and ensuring the safe operation of electrical equipment. The NEC Section 400 covers flexible cords and cables. Flexible cords and cables are used to connect portable appliances and equipment to electrical outlets. It is important to use flexible cords and cables that are properly sized for the load they will be carrying and to inspect them regularly for damage. Damaged flexible cords and cables should be replaced immediately. The NEC Section 408 covers switchboards and panel boards. Switchboards and panel boards are used to distribute electricity to different circuits in a building. It is important to install switchboards and panel boards in a location that is accessible for maintenance and inspection and to protect them from physical damage. The NEC Section 430 covers motors and motor circuits. Motors are used to power a wide variety of equipment, including pumps, fans, and compressors. It is important to protect motors from overloads and short circuits to prevent damage to the motor and potential fire hazards. The NEC Section 500 covers hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. It is important to use electrical equipment that is specifically designed for use in hazardous locations to prevent explosions and fires. The NEC Section 600 covers electric signs and outline lighting. Electric signs and outline lighting are used to advertise businesses and to provide illumination. It is important to install electric signs and outline lighting in accordance with the NEC to prevent electrical hazards. The NEC Section 700 covers emergency systems. Emergency systems are designed to provide power to essential equipment during a power outage. It is important to test emergency systems regularly to ensure that they are functioning properly. The NEC Section 800 covers communication systems. Communication systems are used to transmit and receive information, such as telephone, data, and video signals. It is important to protect communication systems from electrical surges and lightning strikes to prevent damage to the equipment. The installation of a subpanel in a bedroom specifically for AFCI protection presents a nuanced situation under the NEC. The primary concern revolves around the definition of a branch circuit and whether the feeder supplying the subpanel must also be AFCI protected. The NEC defines a branch circuit as extending beyond the final overcurrent device, which, in this scenario, would be the AFCI breakers in the subpanel. However, the argument can be made that the entire circuit from the main panel to the bedroom outlets should be considered a single branch circuit, thus requiring AFCI protection for the feeders as well. The alternative, and often preferred, solution is to install AFCI breakers in the main panel. This ensures that the entire branch circuit, including the feeders, is protected from arc faults. This approach aligns more closely with the intent of the NEC to provide comprehensive AFCI protection for bedroom circuits, enhancing safety and minimizing the risk of electrical fires. When considering electrical modifications such as the installation of a subpanel, it is crucial to consult with a qualified electrician or electrical inspector. They can provide expert guidance on code compliance and ensure that the installation is performed safely and in accordance with all applicable regulations. The NEC is a complex and evolving document, and its interpretation can vary depending on the specific circumstances. Therefore, seeking professional advice is always recommended to ensure the safety and compliance of electrical installations.